Now, suppose I ask you to graph these two. Well, 2 to the n and 2 to the x. Very good. So let us continue. Just move this a little bit here. F of n here. N and f of n. And here I'm graphing f of x, x, and f of x. So when n is 1, you have y equals to 2. 1, my y is 2. When n is 2, my y is 4. 2 and 4. When n is 3, my y is 8. 3 and, it goes up here and so on. So if I take a look at the pattern goes this way, and there are gaps because these y values are not connected together. You have separate y values. So you have separate dots. But when it comes to 2 to the x, if I plug in 0, I get 2 to power 0, which is 1. If I plug in 1, I get 2. If I plug in -1, I get a half. So if I connect these together, the graph of exponential function looks like this. A little bit sharper down here. This is your exponential function. What's the domain? Domain is R. You are allowed to plug in anything here, like this case. What's the domain? Domain is R. You are allowed to plug in anything here. But if I ask you, what is the domain of your sequence? The domain is N. You need to be able to count 1, 2, 3, 4. Domain is N, natural numbers. Domain of this function with gaps is natural numbers. There are gaps in between. These are discrete functions with gaps. But for exponential function that you learned at the beginning of the course in algebra, the domain is R. If you look at the shadow on x-axis, the shadow gives you all possible x values, like this line here. The shadow gives you all possible x values, R. But here, if I look at the shadow on x-axis, which in this case, n-axis, natural numbers, you only have these dots, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. So this is the difference between a function in the form of a sequence and a function with domain R. The behavior is the same, but here you have gaps, discontinuous graph, and here you have continuous graph. Here you have, the behavior is the same. Here you have exponential format, but you are not allowed to fill in this gap.